On this page of notes, we are going to begin looking at some early simple identities. We're going to explore this a little bit more in class, and I will be giving you a foldable to help you organize your thoughts in the various steps that you can do when working with an identity. The first thing that I would want you to do is take a look at this top section and just get comfortable with the reciprocal identities and how we can write each of those. I've already filled mine in, so you can pause the video and take a moment to either fill those in on your own and just process those and make sure that you are comfortable with each of these various relationships. The next thing that we're going to look at are what are called the Pythagorean identities. Now, we're given one that sine squared plus cosine squared equals 1. And what that really comes from is the fact that we've been working with this unit circle. And if you look back to our previous notes, you can recall that we labeled this an x and this a y and this is a 1. And if we wrote this equation for this circle, we would understand that a circle with center at origin and a radius of 1 would be x squared plus y squared equals 1. Now, because this is the equation for our circle, and we've previously understood that x could represent cosine and y could be sine, we can rewrite this problem as sine squared x, or remember that could be a theta or any other variable. So sine squared x plus cosine squared x equals 1. Now, there are various ways that we can rearrange this. So if we take the original Pythagorean identity and we divide everything through by sine squared and begin simplifying, we would have sine squared over sine squared, or 1. We would have cosine squared over sine squared, and from up above, we can see that cosine over sine is our cotangent, so we can rewrite this as cotangent squared x. And 1 over sine squared we understand to be cosecant squared x. So we're going to mark this one off. We can do a similar thing on this problem by dividing, start with the same Pythagorean identity, but we're going to divide by cosine squared x instead. So now, sine squared over cosine squared, that of course is going to be our tangent squared. If you're not sure, take a look up here. So we'll have our tangent squared x. Cosine over cosine is going to be 1. 1 over cosine is going to be secant. So secant squared x. These three identities together are collectively called the Pythagorean identities, and they are three identities that you do need to be familiar with. Now, some simple identities that we can practice with. These, you'll notice, are not equations, so it's important as you're working through these to not use an equal sign. You can use an arrow to indicate that something has moved to a following step, but we don't want to use an equality. It'll get things confused later, and you'll want to move things back and forth that don't. So sine squared theta plus 1. When I look at this problem, the first thing that I see is that I have a sine squared. So that makes me think about my Pythagorean identity from up above. What I know is that sine squared theta plus cosine squared theta equals 1. If I rearrange this equation so that my 1 is on this side and I have sine squared minus 1, I can move my cosine squared to the other side and understand that this would be equivalent then to a negative cosine squared theta. And that would be your final answer. We're just going to simplify these down to, usually it's one or two trig functions. Cotangent squared theta minus secant squared theta. Again, we can think about our Pythagorean identity that we just discovered from up above. We understand that 1 plus cotangent squared theta equals cosecant squared, forgot to write my c there, sorry, cosecant squared theta. We understand that this relationship is true. So if we rearrange this so one side of it looks the same, so I would have cotangent squared minus cosecant, so I would move the cosecant squared over. which means I would need to move the 1 to the other side. You'll notice that I am just doing these mentally, and that's what you would want to do as well. Now when I have two functions that are being added together, or subtracted in this case, it's important to get common denominators. So I'm going to put my second term over 1. My common denominator would be cosine. So I'm going to multiply the top and the bottom by cosine theta. So I get 1 minus cosine squared theta all over cosine theta. 1 minus cosine theta squared theta, again, thinking about this Pythagorean identity, if I move my cosine squared to the other side, I would be left with sine squared theta then for the top over cosine theta. Now, I can do this in my head, but I'll split it apart for you. Notice I'm using an arrow, not an equals. Sine squared theta is sine theta times sine theta over cosine theta. Sine over cosine then simplifies to be tangent theta times sine theta. Typically, when we write these, we do not want to leave any fractions if we can avoid them. Secant squared minus tangent squared theta. This isn't much different than what we were doing earlier, so we'll rewrite that Pythagorean identity if we want. If I want to rearrange this, I'm going to move my tangent to the other side, leaving the 1 alone. So that's my final answer. Back to subtracting some identities. So I'm going to get my common denominators again, tangent over tangent. So I have tangent squared theta minus secant squared theta all over tangent theta. Tangent squared theta minus secant squared theta. We've already written this identity right here. All I need to do to rearrange this so it looks the same is have the 1 and the secant flip places. So this can be rewritten as negative 1 over tangent theta. Remember, we don't want any fractions, so I'm going to rewrite this as a negative cotangent theta. The last thing that we can do is we can simplify, and this is one of our other skills that we'll do, and rewrite everything in terms of sine and cosine. I also like to take my fractions when I have some multiplication in here and split them out into all their individual fractions. So I'm going to rewrite this problem as cosine 82, and I'm going to put it over 1 as its own fraction. My tangent 82 that's in the numerator, I'm also going to rewrite in terms of sine and cosine. So I'm going to write that as sine 82 over cosine 82. And then I have an 82, a sine 82 in the denominator, and I'm going to rewrite that as 1 over sine 82. Now I can quickly see that everything is going to cancel, and my final answer is 1.